This morning we looked at long division, and there's the example that one of the examples that we did as a warm-up this morning. Now, mathematicians are inherently lazy, so we've seen a number of things where they write things in shortened forms, like XER, instead of having to write out X belongs to all real numbers. We got things shortened. So this long division with polynomials probably bothered some mathematicians just because you have to write a lot. So is there a way that we can take exactly what we did there and make it shorter? So it used to be that you would learn long division in grade 10. It used to be part of the grade 10 curriculum. And you would do long division all grade 10. And then in grade 11, they would teach you the shortcut. Now they put both of them in grade 12, and we learn the long way in the morning and the shortcut in the afternoon. So this is what the shortcut would look like for this one. Instead of writing 3x squared minus 4x and 5, I just write 3 minus 4 and 5. Not too bad. And instead of writing x minus 2, I just write positive 2 out here. And this is how the shortcut goes. Bring down the 3, 2 times 3 is 6, add, get 2, 2 times 2 is 4, add, get 9. So the answer is 3x plus 2, remainder 9. Is that the same answer we got there? Was that a little bit faster to write? No. This is called synthetic division. Whew, that was pretty fast. So we're going to have to rewind a little bit to say what we did. So in synthetic division, you have placeholders, just like numbers have placeholders. In this case, this was our x squared, these were our x's, and these were our constants. I'll just put C for constants there. So we had 3x squared minus 4x plus 5. And so I just wrote 3 minus 4 and 5. That saved me some time, since I didn't have to write the x squared, the x, and the plus and minus signs in between. Okay? When you're dividing by x minus 2, you always put the opposite sign value on the outside. Now the reason we do the opposite sign is when you've done long division and you check your answer, the number one mistake you make is with subtracting, because subtracting negatives and all that, you're going to make more mistakes subtracting than you are going to make if you add. And so by changing the sign from a minus 2 to a 2 there, it allows us to add instead of subtract, which makes us make a few less mental math errors. Now, one of the patterns that you may have noticed when you underlined, remember we underlined this first value and said, what would we have to multiply x by to get 3x squared? It always was the same coefficient to start with when you have just a plain x here. And so synthetic division, when we learn it, is only going to work in certain situations when you're dividing by x plus something or x minus something. If you're dividing by anything else, like 3x plus 5, you will have to go back to long division. We're not going to learn. There is techniques that you can, new synthetic techniques for that as well, but we're just going to learn synthetic division when we're dividing by something like x plus 1 or x minus 5 or x plus 3. So with that in mind, that's why we always bring down the first value, which is 3 in this case. The next thing you do is you'd multiply 2 times 3. 2 times 3 is 6. And then you add to get 2. Repeat this process. Now we would do 2 times 2 to get 4, and then add to get 9. The last number is always your remainder, and then you work backwards, so then this would be your constant, and this would only be 1x. And you always have your highest degree 1 less than you started with because you've divided. So this is called synthetic division. If you want to highlight it in your notes, it's on page 5. You can take out our highlighter. synthetic division, and they have an example here which goes through the steps. Right? So we're always writing down the opposite sign here for the 2. Opposite sign there for 2. Then we write our coefficients down. The very first number is always the number that you would bring down. And then it's a process of multiplying. So you'd multiply 2 by 5. That would get you 10. And then add. Now you get 17. So now you would take 2 times 17 and put that there, which is 34. And then add. So this allows us to do the long division and get our answer really quickly. But it's a little bit harder to see where the numbers come from because it is a shortcut. So it's nice to think back, okay, why do these things work? How come they work the way that they do? Well, if we look at the pattern of what we did in long division, right? We always found our first term. In this case, it was 3x. We took that 3x and we multiplied. And when we multiplied, right, that 3 hit this 2, which is what's happening right here with this 3 hitting that 2. And it gave us 6. So it gives us 6 there. Now, when we were subtracting the negative, you would have gotten 2, but now we're adding because we already took the negative sign out, so we still get the 2. And that 2 became your new first term. So then that 2 would have to get, right, that 2 when it gets multiplied by here, it gives us a 4. That's what happens right there, giving us a 4. And when we add those, we get a remainder of 9. So let's look at our first example with synthetic division. Our only example is synthetic division. This one's pretty straightforward. With synthetic division, things that you have to be careful with. Here, the order really is important. So you have to make sure that your order is from highest degree to lowest degree. And in this example, it goes from a degree of 4 to degree of 3, 2, 1, and then our constant. This one's already written in the right order. But be careful, because if you write your numbers in the wrong order, it's like writing a real number in the wrong order. It doesn't make any sense. The other thing you have to be careful with are any of the degrees missing. Because if a degree is missing, then you're going to need to add a 0 in there. We write the coefficients, -3, 2, 3, -4, 5. No zeros in this case, so that's helpful. We write the opposite sign, so we're dividing by x plus 2, so the opposite of plus 2 would be -2. We write that out in front. So I'll color code things a little bit. First thing you always do is bring down that first number. So it's going to be a -3. And then the process is you multiply these two together, you get 6, and then you add. Then you repeat this process now that with our 8, now we multiply our 8 by the -2, -16, and add. Multiply our -13 by our -2, giving us +26, and add. And finally, multiply our 22 by our -2, -44, and add. This question does say to write the division statement. That is our Dairy Queen statement with our remainder. So our polynomial was negative 3x to the 4 plus 2x cubed plus 3x squared minus 4x plus 5 equals, we divided by x plus 2. As an answer, we've got all of this. So what does that mean? The last one's your remainder. This is going to be, the 22 is your constant, negative 13x, 8x squared, and negative 3x cubed. It should make sense that if you're dividing by something with an x plus 2, that your first term needs an x cubed in order to get your x to the 4. So we'll get negative 3x cubed plus 8x squared minus 13x plus 22. And a remainder is negative 39, so we can go subtract 39 in the end. This was our original polynomial, our divisor, our quotient, plus our remainder. It is a big answer in the end. So I'm going to get you to try some of these. 8, 9, 11, and 12.